in the previous lecture, I was explaining concept called moving. In this lecture, we'll continue in this topic, and I'll provide you some additional explanations. All right, so let's remove all of this here in the main function. We'll start with something new. Okay, I'll create here our variable as we had it before, a message. I could keep it, but all right, let's create it one more time. Message string from, and this will create a new string. Let's say hello again. Okay, then I will create a new function under function. Let's call it just a print message. This will accept string. Remember, this is not end str, but a string type, so you can write it like this. Let's say this will be a, we'll call it a, and string like this. Then in here, we will simply print line, and we'll print line here this a, okay? Actually, we don't need to print line here anything, but for you just to see that we have here something, we'll print line here, actually like this, a. And here I'll create a c, and let's see, and we will assign here a, like this. And under, in the main, we'll write here print message, we'll call the function, I will write here message. All right, guys, so now I would like to see how this, what's happening in the stack, what's happening in the heap, okay? So let's see Carbo here. I will start drawing here, and again, I will write here this linear stack memory, stack frame, okay? Because I think it's easier to grasp this concept when you have like this. Okay, so here will be our stack, okay? So it will be stack. Okay, so what's happening here? We have here message, you know, that's a pointer. So we are creating here message. Okay, this message variable, that's a pointer to actual message value. Okay, so we have a pointer. Again, capacity length will be 5.5. This will go to the heap memory. And this will allocate, this will create the actual value of the hello in the heap, which will be with the address of the pointer on the stack. I'll just write hello like this, okay? I will not write here any cells, anything, just like this, so it's simplified. And that's our message. That's our message. Another message. Okay, then we are calling here a print message, and we are providing our message into the main. Okay, that's actually a different stack frame. And yeah, imagine this is also a different stack frame here. So this was our main function, and here we are going to print message function. Okay, so here will be the stack frame for the print message. Here is this is the stack frame for the main function. Okay, so here we are getting into the context A. Okay, so that's our message pointer here. So we are copying just a pointer, as remember. So again, the message got into the print message. So our A now will be the pointer. This will be A. And it will be again pointer, the same values. It will be pointing to hello. Okay, I will be providing here but assumptions here. Okay, so I am not assuming that anything was moved. Of course, it was moved, but let's assume it wasn't moved. Okay. Now, as you can see here, we are moving A to the C. Okay, so the same thing here, we are creating here C pointer, because A pointer was moved to the C. Okay, so pointer 5.5, this are C, again pointing to the same thing here. All right, and now to the important part, guys. So, as you know, when the stack frame is finished, so we don't have anything here to execute, that's a finish, we don't doing anything here. So this means the stack frame becomes invalid. Okay, pointer will move back to the main function. This becomes invalid. Nothing is cleared here actually. It just becomes it will be able to be overridden if the next instructions are provided or the next function is called. But let's assume it's removed. Okay, let's assume that we are going back to main function. It is removed. So this means we are starting removing the things from the stack frame. So we are going to remove the C. Okay, and we are going to remove the underlying memory in the heap. This means we would remove the hello, and also we would remove this pointer here. We would remove here this. Then A, we are going to clear A. This would be removing A and also the underlying memory, but there is nothing in the memory. So we would have here, again, we would be clearing the empty memory. This would cause the error. And what could happen even worse is that in the meantime, after we have removed the C, this memory would be cleared out and something new would happen. So we would be assigning some new variables and new values, and they would be stored at the same place where the hello was before. And we would be getting here some new values or maybe some very important information. We will be clearing it out with this pointer here, because this pointer would be pointing to some address where there is already different value. Okay, so we would be clearing out something that we shouldn't be. Okay, so you can see there is a lot of problems when we're not considering moving. Of course, we are considering moving. That's what should happen. So now let's consider the good case. Let's imagine, again, we are starting from a message, getting pointer, pointing to the hello. Now we are calling the print message function. Print message function which get called in this stack frame. We are creating the a variable, which will be the pointer pointing to hello, and this means the message was moved to this function. Okay, so this message will become invalid now. I will mark it that it's invalid, just basically blanking it out. This will become invalid now. It was moved to print message function. Okay, so now we have only a. Then we are creating the C, and this means a was moved to the C. So a is also being moved, and it's becoming invalid. So now when the print message function is finished, we are going to clear it out the things. We are just clearing this. We are clearing the underlying memory of the hello, and we are not clearing the memory for the a and the message. They are popped out from the stack, but the memory is not cleared any longer. Okay, so that's how does it work. One more thing. On these dynamic types, usually you have a function that's executed that it's clearing this memory, and this function is called a drop function. So whenever your stack is finished and it's getting out of the scope, so when you print the message function, this print message function is finished executing, then the drop on the pointers is executed. So there is something called drop. There's something called drop on the C, and this will clear the memory. Okay, so it's not getting cleared automatically, but because you have this drop defined on the C, it's something called trait. I will be talking about the traits later, but that's happening. This is something what's happening automatically in the Rust when your values are getting out of the scope from a function. So function is finished. Basically the drop function is called, and this will clear the underlying memory. And you see when the values here were moved, the drop is not called here any longer. This drop is not called here for these values here. Okay, so that's why we are clearing only it for this. Okay, I'll write also here, so it's more clear. Okay, so just 1 second. Okay, so I'll write here a few comments. Okay, message coming into the scope. Okay, that's what's happening. The message is created, this message is coming into the scope, it's created on the stack, and so on. Also, the heap memory is allocated. Now, message is moved into the print message. Message is moved into the print message function. Okay, from this point on, message is no longer valid. So if I will try to do here something like print line, and I will try to print here my original message, it has been moved, so it's considered to be invalid. Okay, so you can see here value was moved, value was borrowed here after move, so this is considered to be a forbidden operation, and we cannot do it. This will be not compiled simply. Okay, so message is no longer valid here. Then the print message is called, and this means the A is coming into the scope. A comes into the scope. Scope here we are using A, no big deal here, and here we are moving A. Okay, so here moving, all right, so right here A is moved into the C. Okay, and C is coming into the scope. Actually, I should write it other way around. Okay, C is coming to the scope, and A is moved into the C. So from this point on, 8 is considered to be invalid. So when I will try to do again display here in print line A, I will get here issue. Okay. Okay, so I can actually write here message is no longer valid. So I'll write it here. A is no longer valid. Okay, and here when we are finishing the function, when this function is getting out of the scope, there are no other instructions to be called. Here we can write that our variable is going out of the scope. So let's write first for a. So a is going out of this. A is going out of the scope. So a is going out of the scope, but nothing more will happen because it was moved. It was moved. All right, so A is going out of the scope, but nothing more will happen because it was moved. And C is going out of the scope. And drop, as I mentioned before, a drop is called, which clears the underlying memory, from the heap. Okay, so A is going out of the scope, but nothing more will happen because it was moved. C is going out of the scope, and the drop is called, which clears the memory from the heap. Okay, it's not happening from the A because A was moved. It only happens for the C, and we are calling the drop, which will clear the memory from the heap. And here the same message. Actually, I will copy this line here. Message is going out of the scope, but nothing more will happen because it was moved into print message, and then print message is responsible what will happen with the memory. Okay, from this point on. Okay, so that's the memory management in Rust. Okay, that how this memory is allocated and how the memory is deallocated. Memory is deallocated whenever your variables are going outside of the scope. So when the function is finished, then the drop function is called and the underlying memory of your heap values is cleared out. For the values that has been moved, the memory is not cleared out, only for the active variables where the values were moved into. Any questions to it, feel free to ask. More of this concept, I will include the links in the description, so maybe you can read after the lecture. That's gonna be it, guys. I will still continue with these topics because there are some important notes I need to still mention, but let's stick with me and let's get over these topics and let's then go into the real project. Okay, guys, so that's it, and see you in the next one.